Thank you. I want to know who has heard about CQRS before. So there's a couple of hands. And are there also people that have implemented the CQRS architecture currently in production? So there's 2, I think. Like with the lights, I can't see it really good. So what I will be covering. So I will talk a bit about state. Like normally, if you use CRUD, then your state is in the database, and some things are easier and other things are much harder. Then something about CQRS, some of the advantages, disadvantages. Then I will tell something about the demo application I will be using, which starts out pretty easy, but it could be much more complex later on. Then how you can combine CQRS with GraphQL, and then I will show the demo with also some subscription queries, and also some reflection on what I saw. So a quick bit about me. 4 years ago I was also speaking at GraphQL Summit, then about using Kafka for subscriptions. Back then subscriptions were still pretty new, and I think still there's not. Can I see hands who is using subscriptions in production? So still not that much used, so I was very glad to hear it in the keynote, so that's nice, and also that it's working with Federation. So there's also the bass guitar, so now and then I try to play bass guitar, and now it's been almost a month that I haven't played, since I've been very busy also preparing this presentation and stuff. But I'm looking forward when I'm back home to start playing again. So I'm working with Axonic for about 1.5 years now, mostly working on the framework itself, which is an open source framework which they started on about 15 years ago. So that's quite a long time. And I'm also thinking with Rust sometimes, which one library doesn't really have anything to do with GraphQL, except that it's getting more popular over time, and that is also doing something with data transformation. So it's now at about 1,000 downloads a day on a good day. So what about state? If we use CRUD and just, let's say, to keep it simple, single database, then it's very easy to do things. Like you can, for example, use Hasura or something. You can just create your database schema and you can get all your resolvers practically for free. But you don't have any history. So if you want that, it becomes more complex. So what about CQRS? So CQRS starts out kind of complex because you want to split how the commands are handled. So commands are specific messages that display an intent to change something. And the queries are also different. So there are different ways to implement CQRS, but one of the ways is by creating events. So you have a kind of message with an intent to change something that will create one or multiple events. And then those events can be used to build up a data model against which you can build queries. And then you can build different kind of projections. So for example, you could have one with Elasticsearch, so you can easily do based on text. Or you could have some with Mongo, so you don't really care about what's in the document. Or you could use, for example, also Postgres and use it very strict, and then like that. And the kind of advantage is that you can easily just throw away your whole database and then build it up again based on all those events. There's different ways to how the commands work. So one way is to have a state stored aggregate. In that case, you have a separate model and then you keep track of the changes. And another way is to use event source aggregates. That's what I will be using in the demo. And in that case, when there is a command, you will build up the kind of go back in history, display all the events for a particular aggregate, so for a particular group. So for example, the demo is about gift cards, so you display all the events for that specific gift card, and then you build a state. Of course, you can also cache that for performance reasons. But in that case, you have a strong consistency between your command model and the queries. So some of the advantages of CQRS, you can do performance optimizations. So you can have specific read models for specific queries. So for example, with things like Supergraph, you could also, if there's a lot of data that you want to use together, you could put it in the same database. And it's also scalable and more elastic. So for example, since there's always messages in between, you could always, the application that's handling the commands, you could duplicate them and then just send half of the messages, command messages to one application and the other half to the other application, things like that. And what's also nice is that in this way with events, that you have the whole history. So the only thing that that data can be changed is by events. And then in those events, you could store metadata like who created that event. And that's pretty strong. Well, with a database, yeah, you never know what will change. Some of the disadvantages, so when you start up, you have increased complexity because yeah, you have different data models, you need to store them somewhere, you need events to stream from one way to the other, so you need some kind of event bus. So that's all making it more complex to start. And also giving operational overhead. So you need to keep all these components running, monitoring, stuff like that. And eventual consistency might also be a thing because it's not like when there is a command, immediately the data model on the query side is also updated. So you need to find something to work with that. Although you could say that like in the real world, everything is eventual consistent. So a bit about the demo project. It's about gift cards, which is quite simple since there's only a few things that can happen with a card. So you can issue a new card, and then it has a certain amount. Then you can redeem the card, cancel the card, and then there's some queries. So you could get all the cards, or you could get a specific card. So now we're going to the GraphQL things. So if you have mutations in a CRUD application and you're using a database, then it's pretty easy because you just create or update an entity and then return the entity. Queries are also pretty simple because the state is all in the database, and you can use, if you have a schema of the database, you can easily use that to generate your resolvers and get back the result like immediately. And because it's the same of the, yeah. So it's always also immediately consistent since there's just one database. But if you want to do subscriptions on a database, then things become more complex. Like, how do you know that data was changed or not, and why has it been changed? So there are things like change data capture. I'm not sure who has heard of change data capture before. Yeah, so I'm going to explain it a bit. So basically, every database keeps a log of all the changes. And with change data capture, you're kind of reading from that log and create kind of events. But those events are like just this entity has been changed or this entity has been deleted. So there's a very basic kind of events that doesn't display the intent. So now we'll explain about the actual implementation of the gift card. Like I said, I work on the Axon framework, which was designed about 15 years ago. That's an open source framework for Java to do event sourcing, DDD, and CQRS, which is quite a mouthful and quite complex. And as a solution, you can just use Seagull for the event store. And then if you use Postgres, then that works fine for a pretty long time. But since with event sourcing, we don't want to throw away the events. So for example, especially since you want to build up those projections for the queries whenever you want. So because you can't remove those events, after some time you have like enormous amount of events, and for a relational database, all data is equal. So then, for example, your indexes become too large, and you can, of course, add more CPU, but at some point you're running into problems. And that's why they designed, created Axon Server, which is both an event store and a message router. Because, like I said, so you have these command messages, which have need to be handled differently than event messages. So a command message is with a specific intent, and you only want to have it applied once. So you don't want, if you want redeem your gift card, that it's suddenly redeemed twice, for example. So that's very important. Event messages you want to set to everyone that's subscribed for it, so that all the projections are updated. And then Axon also has a different kind of specific message, which is a query message. So you can send a specific query message to Axon Server, and that just routes it to the correct instance so you can do the queries. Then I will use Axon Synapse. That's something that we later introduced, which is using JSON over HTTP, because we don't really like the word REST, because that's means something different to everyone. But that makes it more easy to use Axon Server also from other languages. And then in this case, for the projection, I use MongoDB. Like the framework and our stuff is very, you can use whatever you want. And for the GraphQL endpoints, I'm using Yoga with Deno and then with TypeScript. So this is all the components together. So it's quite a lot to initially start out and some lines in between. So I get back to that with the actual implementations. So if you want to do mutations, you have a command message, but then the result isn't there immediately. So how I implemented it in this case is that you can supply a timeout, and then I will, well, depending on whether the command fails or not. If the command fails, you get back why it has failed. If the command succeeds, it waits that amount of time and then gives you the updated entity. So this is how it would look like if you would execute the command. So from the Deno application, it sends the command message to Axon Synapse. That will be routed to Axon Server, and that will be using a gRPC API, and then the Axon Framework application, which in this case is just a JVM application, will then previously have subscribed to Axon Server with I can handle this kind of command messages, so it will be sent to Axon, to the Axon Framework application. And then it will be routed back. So then if it's successful, event will be created. That event will be sent to Axon Synapse. And from Axon Synapse, it will be sent to the Deno application, since before it started, it's subscribed for all the event messages. Then with that event, it can update the entity in Mongo and then fetch the result. So the mutation that sends the command message will look like this. So in this case, it's creating a new gift card. And then there's, I use the union in this time. So if it's successful, then a gift card is returned, and you have some kind of fields on the gift card that you can use. It can also be that there's an error in handling the command. For example, if the card ID already exists, you get an error. And it could also be that there's a fetch error. In this case, it's always the same reason, which is if the timeout exceeded. So in this case, this is a successful response. So then you get the gift card from the updated Mongo instance. This is, for example, an issue when the GVM app isn't running anymore. So then External Server tries to send a command to the JVM app, but it can't since it's not there. And then, so this is probably for security reasons you don't want this, because it's displaying the internals of the application. And this is even giving more information. So this is the case when there's already a card with that ID, because then it wants to iterate on the given ID, but it can't. And also in this case, well, this is just a demo application, but probably for a real application, you want to catch this error and send something else back to the client. Yeah, so this is the reason in this case is always be timed out waiting for an event. Queries, they are quite, so there's some code with events to make sure when there is duplication of events, that's called idempotency. So when there's a duplication of events, only the last event will actually be really updating the database. So how is it doing that? There's a sequence number for all the events based on the card, and it will check if the sequence number is actually higher than the existing one. And only if it's higher, it will be applying the change to the database. So this is pretty simple for the queries. So for example, you can do a query for all the active gift cards, so then it will also check against that, that there is some balance, and then return the gift cards. Then subscriptions, which is something I really like about GraphQL. I also write, or a bit after the talk 4 years ago when I was at GraphQL Summit, I saw there was an issue for Micronaut to add subscriptions. So because I already seen how for other GVM applications it was done, so I added it, so that's quite nice. So in this case, you can use the event as a trigger for the subscription and then return the updated entities. So again, from External Server, in this case, there wasn't, you don't know what triggered the change, like the application itself doesn't necessarily need to be the one that sent the command. But then from External Server, we get the event, we can update the entity and return it. Yeah, so this is an example of subscription. I will show it live if the demo gods are with me. And now do that. So it's, because there's no initial response, which is how it's built now, but of course you could also have a subscription that starts with the current one. And on the right side, there's the UI from the GVM application, which is just to make things easier. Yeah, so I'm not sure what's going wrong, so everything seems to be running, and it was running fine a few minutes ago. But yeah, you can try it out for yourself. Then a bit on how to handle changes with such a system. So for example, if you would add an expiration date, because currently there's no expiration date, so then every card is valid till eternity, but of course that's not a real situation. So we could add a default time that they are valid. So then we need to determine what to do with the current cards, update also the command message to maybe include the days that a card is valid, and then recreate the projections based on the new business rules. So some reflection, does it fit? I think it's really nice how CQRS matches with GraphQL. So you have really the queries, you can fit them how you want. The mutations match nicely with the command messages, and you get kind of subscriptions kind of for free, since there already are events that triggers them. How generic is it? Well, basically for the GraphQL endpoint, all I need is some way to execute a command and then be sure if it's exceeded or not. And then also some way to get the events. So you can use Axon framework and stuff, but you can also keep it simpler. And then there's also a question how to model. I'm not sure if anybody heard about event modeling. It's kind of a nice approach, but it's very coming from DDD. And then basically you get everyone from the business together. They have a big wall, and you start with the events, and then from the events you figure out what kind of commands you need to get those events. And then you can also display the UI and what information you need in the UI. And of course, if you know all that, then it should also become easier to implement that in GraphQL. So this is the link for the feedback. And if you have any questions, there's my Twitter handle, which is now X, and the link for the demo. So, thank you.